an Excel sheet back before we leave, because I'm really curious to see how it's doing. Actually, I can see it right now. It's gorgeous. Oh, that just makes me happy. All right, so let's change these all to 1/6. Okay, there's our averages over there. How do our average come out?
Perfect.
Perfect. Yes, perfect to one decimal. Hello, Amy. Perfect to one decimal. So the idea is, this is why we sample. Because when you sample, on average, you target your average. And we did a good sample. Good for us. What do you think, what do you find interesting about this screen?
The standard variation.
Look at this.
Yeah.
How the heck, why is that blank?
Because they have the same frequency.
Say that again,
Same
Michelle.
frequency for every single value. So does that
I
make
love
it-
that answer, but here's the deal. The values themselves have variance, don't they? Like there's a difference between 1 and 2 and 3 and 4 and 5 and 6. So in other words, going back to our definition of standard deviation, it's the average distance from average. Does that make sense? So if I take each of the sample data points and I figure out how far they are away from 3.5, and then I average those distances, I should get a number. But what word did I just use that doesn't apply anymore? If I take all the elements in the... If I take all the elements in the... Starts with an S.
Sample.
In the sample. Do we have a sample anymore? We don't have a sample. We threw our sample away, remember? And we replaced it with these 1/6. And what are those 1/6 again? Probabilities that are going to happen. So be brave, be brave. That are going to happen. How many trials? Technically speaking, infinitely many. We no longer have a sample. We essentially, if you will, have the population. We essentially have the population. So here's the deal, friends. The standard deviation is, Michelle, you've got it. The standard deviation is up there.
But it's for the population.
It's this one. That's the standard deviation we can now talk about. Because that's the population standard. Little sigma, the little goofy little sigma, I say, ignore it for now. Ignore it for now, we'll get to it later. Guess what? It's later. Because now we actually have either such a large sample it can be considered the population, or we have a theoretical probability that is the population probability. That's pretty badass. There is no sample anymore. We now have little sigma. I think Bruce talks about this, yes? Because your guys' samples are so freaking huge, you can ignore sampling variability. Yes, now we can. Because the 1/6 are going to happen over time as we try to pull the screen down so we can take a look at that. So the average you just calculated, this is also pretty cool. It's called X bar up there. There's a special symbol for the population average. It's called mu. Mu. Greek letter M. Do you know why they used mu and not some other letter? Somebody actually asked me this at the beginning of class. They said on the quiz, you asked for the sample blah. You said you asked for the sample blah. Is that the same as the average?
Oh, you did.
I asked for the sample mean, and that's why they use mu, because it's the first letter of the word mean. The same reason that sigma for standard deviation. They try to be logical whatever they can. It doesn't seem that way sometimes, I know. I apologize. So your population average 3.5 syncs up gorgeously with your sample average of 3.5 we got over there. And your population standard deviation of 1.7 we got over here syncs up pretty friggin' gorgeously with the sample standard deviation of 1.7 we got over there. Check us out. Check us out. Pretty badass. Now, is that legit? I don't know. Let's look at one more thing before we get the hell out of here. Let's see how our dice are doing. Oh, thank you. How we doing up here? Uh-huh. Scroll back so we can see this. The 6s have stabilized in that second decimal place, haven't they? See that right there in that second decimal place? 0.16 across the board. That is no longer changing. The third decimal place looks like it's fluttering around in a couple of them. Yeah, oh no, look, I lied, because that bottom was now 0.17. It's at 0.17. But if I let it run all night, which I can't do because I'll get kicked out of here eventually, it'll just eventually, every next decimal place takes approximately 10 times longer to stabilize. So you figure it took us about, what, a half an hour to stabilize the first set of 6s-ish? It'll take us about 6 hours to stabilize the next one. I don't want to deal with that, you don't either. So, but realize that it will. Look at the pie chart. It's gorgeous. More on this on Tuesday, yes? More on this. Oh yeah, the dice and the coins, if you don't mind putting them back in the bin, here it is. Just drop them in here on the way out. Thank you guys. We'll play with the coins next time and the board dice. We'll bring them back. I knew we were running out of time today. Have a good weekend. Stay safe as this stuff melts and freezes.
Repeatedly.
No margin of error on safety.